So chapter 4, this is the last section we'll be working on, 4.5. This is inequalities involving quadratic functions. So we're going to add this to your bag o' tricks of you've done linear inequalities, absolute value inequalities. Now this is a different type involving quadratic functions. So that's the only objective, is to solve this type of inequalities. And we begin by thinking about the graphs of quadratic functions to see what they can tell us about where the values of the function are positive or negative. So once we have learned about the concept, we'll learn how to solve inequalities. And we're going to learn about the concept graphically, so with pictures first. Then we'll learn how to solve the equations algebraically, but you're going to keep in mind the graphical interpretation of your answers. So when we want to solve an inequality of the form ax squared plus bx plus c is greater than 0 or less than 0, we know we can graph the function f of x equals ax squared plus bx plus c. And it's going to be a parabola. And since we know f of x equals the y values, we'll be looking for values of x where the y values are either greater than 0, positive, or less than 0, negative. So this is saying, where are the y values positive? And this one's saying, where are the y values negative? And when I say where, I'm always meaning for which x values. Okay, so let's look at this picture first. So A says, where on the graph are y values positive? So here's the part of the graph where the y values are positive. But now they're asking us to say, in terms of x values, where is that happening? So it's this piece of the graph and this piece of the graph are the pieces where the y values of this function are positive. So it might be easier to start out looking at the negative part and saying when x is from -3 to 3, so on the interval from -3 to 3, y is negative, right? So remember that you can translate this interval notation back into an inequality and see if that makes sense to you. For x values between -3 and 3, so all these x values in here, the y values on this graph are negative. Yeah, it looks right to me. So the y values are positive when x is everywhere from -infinity up to -3. And then again, from x is bigger than 3 and on. So the first interval notation is for the -infinity to -3 part of the graph. And the second part of the interval notation is for the other piece of the graph. So every function value has to either be positive or negative or 0, right? Those are the only choices. So this says, where are they strictly positive? Basically, this is everywhere else. Where are they negative or 0? Well, that's going to be on the interval from -3 to 3. And now we need to include the endpoints because the equal to 0 is included in the problem statement. So for all values of x greater than or equal to -3 and less than or equal to 3, the y values on this function's graph are negative. Okay, so let's look at another one, and we'll do this one in class together. Okay, so now we make it a little trickier, and we have graphs of two functions. So keep in mind that you're analyzing the graphs of the functions by looking this way. But then when you're being asked about values of x, now you're thinking horizontally. So the A part says, where is the g function bigger than the f function or equal to the f function? So here are the points where they're equal. So g of x equals f of x when x equals -2 and when x equals 1, right? So those are definitely going to need to be included in our interval. Now g is the red function. So this says, when is the red function above the blue function? And again, as I'm looking this way across the graph. So the red function is above the blue function over here. Oh, maybe not. It looks like if we continue them on, the blue one will be higher values of y. So this region in here, here's where the red function is above the blue function. If I pick a value of x and I look up, the red is higher than the blue. Then over here, it's easy to see that the blue is higher than the red. So the red is above the blue from the interval x is -2 up until 1. And remember, this is the inequality with the endpoints included. So for values of x between -2 and 1, the red function is above the blue function. And then again, this other part is saying, where is the blue above the red? Well, that has to be everywhere else, right? So from -infinity to -2, not including -2, and from 1 to infinity, that's the answer to the B part, because it has to be everywhere else. You're either above or below or equal. Those are your only choices. Okay, then we'll work on this one together in class. So now that you have a mental image to go with what we're doing, let's try solving some problems with algebra where we don't have a picture. We can draw a picture after the fact to kind of verify what we're doing, but make sure you're very clear that the steps, the strategy for solving these is very different from solving linear equalities or from solving absolute value inequalities. So you need to classify them. Oh, this is a quadratic inequality, and then remember that there's a different way of solving them. Okay, so this first one, we're always going to be wanting to factor and say, let's see, this looks like x plus 5x minus 2 is bigger than 0. That looks right. So you cannot simply say, oh, well, then x plus 5 is bigger than 0 or x minus 2 is bigger than 0. It won't work. You must temporarily replace that inequality with an equality. So this is just a temporary step. And then you can see that either x plus 5 equals 0 or x minus 2 equals 0. So x is -5 or x is 2. Then you need to put these points on a number line. And this is the same number line as the x-axis in the pictures that we were looking at. We just don't have a picture. So now we just have to figure out where this parabola goes. So if you look at the equation of the parabola, you can see that it has a positive coefficient on the x squared. So we know that means it's opening upward. And what we found when we set this equal to 0, we found the x-intercepts. So we found out that these are the x-intercepts where the graph crosses the x-axis. So we can see that the function must be negative in this area because we know what the picture looks like. But let's see how we can convince somebody else. So when we put these endpoints of -5 and 2 on this number line. We have separated the number line into intervals from -infinity to -5, from -5 to 2, and from 2 to infinity. So the way I'm going to show you to do this, we'll keep working for harder problems. For these problems, it's a little bit overkill, but it's a really good strategy that will be useful later when you're doing harder functions. So let's go ahead and start practicing it now. So the idea is that you pick a test point that's in this interval, and I'm going to suggest that you use numbers like 1 and 10, -1, -10 that are in the interval, because the arithmetic's a lot easier then. So what happens when I put x is -10, then I put it in the inequality, and I'm asking the question, is this true? When x is -10, is the value of the function bigger than 0? And I'm going to say yes, it is. So this is true or false. So I'm going to say yes, it's true. So that means I want this piece of the number line. That is the region of the x-axis where the y values on this parabola are positive. So now let's pick a simple number between -5 and 2 and 0. If 0 is available, pick 0. Because then if you plug 0 into the function, you'll see that it's not true. The inequality is not true when x is 0, so you don't want this section of the number line. Well, why can we just pick one point? Because those points, -5 and 2, are the only points where the graph can change signs. It's the only place where it can go from positive to negative or negative to positive. So you only have to check in one place in the interval, and if it's true at one spot, it's true at every spot in that interval. If it's false at any spot, it's false everywhere in the interval. So you only have to check one point. So then let's check a value between 2 and going up, and 10 is an easy one to pick. And 10 squared plus 3 times 10 minus 10 is definitely greater than 0. So we want this piece of the number line, and we want this piece of the number line. We don't want the endpoints because it's a strict inequality. So your answer is going to be -infinity to -5 union with 2 to infinity. So any value of x smaller than -5 or bigger than 2 will give you a true inequality for this function. Okay, and then we'll draw the graph together and look at the picture and make sure it's making sense and hooking together. So we'll do the other two in class together to talk about the little details. So this last question is a sneaky way of hiding a quadratic inequality in another problem as a domain question. So remember, when we're worrying about square roots, we're saying, oh, the stuff inside the square root has to be positive, or it can be 0. So if you write what I just said in words as a mathematical sentence, we get x minus 3x squared is greater than or equal to 0. So now this is a quadratic inequality. So we'll solve that one together also.